Now in this video, let's look at the product of sets. So what is the product of two sets A and B? Let's say you have two sets a set A and a set B. Then what is A cross B? So we have seen different set operations like union, intersection, set difference, set symmetric difference between two sets. And the result of it is also a set. This is also one of the operation, set operation. And the result of this set operation is also a set. Okay. A set is an unordered collection, but the result of it is also an unordered collection, but unordered collection of ordered pairs. So this is a very important point. So A cross B will give you set, no doubt set, which is an unordered collection. Unordered collection. So set of all possible ordered pairs. Set of all possible ordered pairs. Okay. So what do I mean by this ordered pairs? What is this ordered pair? Okay. Like let's say if A is 1, 2, and 3, and let's take B to be A, B, C. Then what is ordered pair? Means that this is equal to a set. This is a set which is each element of it is a pair. Each element is a pair of element. Means each element is a pair x and y, where x belongs to A and y belongs to B. Okay, such that x belongs to A and y belongs to B. So for every A, what are the ordered pairs possible between A and B? 1 and A, 1 and B, 1 and C. Because for every A, it will come, each element of A will come with each element of B. With the in this ordered pair, why it is called ordered pair? Because the first element of this pair has to be from set A, and the second element of this pair has to be from set B. So this pair is ordered pair, but because this is a set of ordered pairs, so okay, let me first write all of the possible ordered pairs. Okay, so all possible ordered pairs is 1 and A, 1 and B, 1 and C, 2 and A, 2 and B, 2 and C, 3 and A, 3 and B, 3 and C, right? So with A, A has to be paired with each element of B. So you have this. Similarly, 2 is also an element of A, and each element of A has to be paired with every element of B. So 2 will be paired with A, 2 will be paired with B, and 2 will be paired with C. That's what this is. And similarly, 3 will be paired with A, B, and C, and that's what this is. Okay. So a set A cross B set will be equal to all of these elements. And because it's a set, the order is not important. So each element is an ordered pair, but there is no order of the, it means each element is an ordered pair, but you can't say what is the first ordered pair, what is the second ordered pair. You know what I'm saying. So it can be 3A, 1A, in any order you can write it. So it's a set, but each element is an ordered pair where first element belongs to A, second element belongs to B. Now you may be thinking that what is the use of it? What is the use of this product of sets? One of the use is in the combinatorics actually. the multiplication rule that we will see very soon. The multiplication rule, the ways of doing things if you want to accomplish a task, and basically there's task T that you want to accomplish, but accomplishing task T means that doing T1 and T2. And let's say there are m ways of doing T1 and there are n ways of doing T2. Then how many ways you can do the task T? Okay. Should I explain multiplication rule right here? See, if let's say you have to accomplish a task T, and to complete task T means doing task 1 and task 2 both, and task 1, for doing task 1, you can do it in m ways. Okay, let's say x1 is one of the way you can do, x2 is another way you can do, and so on so on. There are m ways to perform task 1, and there are n ways to perform task 2. Okay, n ways to perform task 2. Then if you, let's say, if you take any ordered pair means that first element of this ordered pair has to be from T1, and second element from the ordered pair has to be from T2. Then any ordered pair is one way of doing T. Any ordered pair is one way of doing T, right? So if you take x1 y1, I don't know if it is visible or not. So x1 y1 is one way of doing it. X2 x1 y2 is another way of doing it. Another way of doing it. Okay. So in multiplication rule says that if the number of elements in T1 is m and number of elements in T2 is n, then number of ways of doing T is m into n. This is a multiplication rule, because how many ordered pairs you will get is actually m into n. So number of ways of doing T is number of ordered pairs. Okay. And I am taking the ways, T1 to be a set. Okay, this is the fundamental of multiplication. T1, you can think of T1 as a set where each element is distinct way of performing T1, and T2 as a set means task T2. You can think of it as a set where each element is a distinct way to perform T2, and number of ways to perform T is the ordered pair between T1 and T2, ordered pair of T1 cross T2. Okay, number of ordered pairs of T1 cross T2. Okay, I will cover multiplication rule again separately. Just showing that how where it is applied. Actually, this is a fundamental rule of counting. There are two fundamental rule of counting: the sum principle and multiplication principle. Here, the constant is that for T to accomplish, both has to be performed in a sequence. Okay, in a sequence. First T1 has to be performed and then T2 has to be performed. The sequence can change. Let's say there is another task T dash. For T dash, T2 has to be performed first and T1 has to be performed first. The number of ways would not change to perform. Then the number of ways for T to complete T1, T dash or T is same. That is m into n, because multiplication is commutative. But the ordered pairs will not be same. Ordered pairs will not be same. Okay, in to accomplish. So tell me, what are the ways to do T dash? The ways to do T dash would be now y1 x1, this is one way, y1 x2, this is another way, in this manner. Anyways, multiplication rule is not to be covered here. That's a separate topic of in combinatorics. Similarly, there is a sum rule. In sum rule, we will see how the union operation of set comes into play. Okay, so set is, that's why in the very first introduction to a set, I told you that the sets are very important, because building upon set theory, other concepts are derived, and set is very fundamental. Just think about what is a set. It's just a collection. So collection is a very fundamental thing. Anything, anywhere there is a collection, you can think in terms of set perspective. TOC is completely uh, like set membership. TOC can be summed up as a set membership problem. Anyways, so this is your A cross B. What about if there are three sets? What is the product? We are talking about product of sets. This is a product of two set is set of all possible ordered pairs. But what if you have three sets? What if you have A cross B cross C? A cross B cross C. Then this is a set of all possible ordered pairs. No, it is not pairs anymore. Means it's a set of an ordered entity, but that entity is a ordered tuple, three tuple. Actually, the ordered pairs means these ordered pairs are two tuple. You can think what is a tuple now. Right now, I will also relate it with relational uh, database. So in database, there are different types of database, but relational database is when you are storing your data as a relation, which is actually a table, and each row is called as a tuple. But each row can be thought of, means it is based relational database is based upon the concept of relation only, and each tuple is actually a k tuple. For example, okay, before I explain, let me just write is a set of all possible three tuple, and I will explain what is a tuple. Okay, so let's see a case of a relational database or relation. If you are very new to the computer science and database is something that you have never heard of, then also you can understand it. Database is a uh, record keeping of entities, like, let's say, look at it. Let's say there is a university, and university is keeping a record of students. Okay, keeping a record of students. Then every student must have some student ID. It's like a register. Student ID, student name. Okay, subjects. Okay, so student ID, let's say first student is Gulam. Okay, and he studies subjects. The subject that he studies is computer science and engineering. And second student name is Moinuddin. Okay, and he studies, let's say, machine learning. Okay, machine learning comes under computer science. Artificial intelligence also comes under computer science. Okay, he is a master of physics. And there is a third student. Let's say his name is Ramesh, and he is a master of mathematics. Oh, sorry, he is a student of mathematics. Okay, and grade is that they are all are toppers, always A plus, A plus, A plus. Okay, so in this case, every row, each row is information about one entity, which entity is a student. So one row contains all the information about Gulam, all the information about this student. Second row consists of all the information about Moinuddin. Third row consists of all the information about Ramesh. And each row is called as tuple. Each row is called as tuple because it's an ordered quantity. Means the first element of this tuple is a number that indicates student ID. But if you just take out the tuple out, if you just take the tuple out, then first element has to be a number. Second element is a string, which is a name of the student. Third element is a string, which is a student subject. Fourth element is a okay, हटा दो, प्लस हटा दो, यही लिख दो, आउटस्टैंडिंग कर दो इसको, ओ ग्रेड. Fourth element of this tuple is a grade. So this is a four tuple. This is a four tuple. Something like this: one, two, three, four. Then you say it's a four tuple. If the order is important in this collection, then it's a tuple. So A cross B is set of all possible two tuples. Okay, set of all possible two tuples, where so two tuples means ordered pair. The first element belongs always has to be from A, second element always has to be from B. Similarly, in this case, A cross B cross C, this is a set of all possible three tuple. Three tuple means you had three elements in a tuple, where the first element always has to belong to A, second element always belongs to B, and third element has to belong to C. And all such tuples possible is your in your product of sets. You have all such three tuples. Okay. In database, when I will start, I will again explain this. So you can think in database also, each of this is called attribute. Okay, that student id is one attribute of the student. So this is your student table. Then each of these is one attribute, is the attribute of a student. So you can think of every attribute as a set. Then there is something called as domain, that this set will have a domain. Okay, the content of your table is going to be a subset of cross product of each of this set. Means all of these elements are tuples, and they are a subset of cross product of these sets. A set student id set cross student name set, cross product with subjects, cross product with grade. Okay, let's complete this set of product of three sets. So this is equal to nothing but x, y, and z, such that x belongs to A, y belongs to B, and z belongs to C. Okay, so let me take one example to explain. Let's take A to be 1 and 2, A and B, and let's take C to be P and Q. Okay, you will see that the number of elements in A cross B cross C is going to be 8. Actually, the number of elements, the cardinality of A cross B cross C is equal to cardinality of A into cardinality of B into cardinality of C. Every element of A, all possible pair. So for A will be connected with, one will be connected with A, then A with P and A with Q. So one A and P is one three tuple, and then one A and Q is another three tuple. Similarly, one will be connected with B, and B will be connected with P and Q. Another two three tuples are one B and P, one B and Q. Likewise for two. Okay, so two A and P, two A and Q, 2b and p, 2b and q. Okay. So as you can count the number of elements, 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to number of elements in A is 2 into 2 into 2, which is equal to 8. So in general, so I have taken two cases, product of two sets, and I have shown that product of two sets is a set of all possible ordered pairs, which is a set of all possible two tuples. Product of three sets is set of all possible three tuples. Similarly, you can, let's say there are k sets. Then product of k sets is what? Set of all possible k tuples. Okay. And what is the number of elements in the product of k sets? It is equal to the cardinality of each set product of the cardinality of each sets. So when we have product of sets, the cardinality of the product of set is equal to just product of their individual cardinalities. I don't have to. I don't think it needs a proof. It's a straight. But let me show it. Let's take only. Let's take first two sets, and it will be easy for me to explain. Let's take two sets A and B. What is happening is that if this is your set A and this is your set B, then every element of set A is connected with every element of set B, right? So if let's say set B has m elements, n elements, let's say set B has n elements, then A has m elements. Then for every element of A in the ordered pair, in the set of all ordered pairs, each element is each element of A is adding n elements. Okay, each element of A is adding n elements. So this is your first element, let's say A1. So A1 is adding n elements to the set of ordered pairs. M elements, sorry. Similarly, A2 will add, because then now A2 will be connected with each element of B. So A2 will also add n elements, and so on. All the m elements are going to add n elements. So what is the ordered pair? It is n plus so on m times, which is equal to n into m. Okay, which is equal to m into n. Now, if there are three sets, if there are three sets, let's say there is another set A, B, and C, and C has, let's say, p elements. Now, your three tuple, your three tuple is going to be something like this, where these two, this is the this place is for element of A, this is place is for element of B, and this place is for element of C. Now you know that you already know that set of all possible ordered pairs is this part. This part is going to be m into n. Let me just replace it with m into n. What I mean is that this is my A cross B. Okay. So of course this is going to be, let's say, one ordered pair A1, A2, and A1, A1, B1, A2, B1, A2, B2. Okay, don't take it as a set. Why I'm doing so? Because then I will explain in a while that why I'm not doing it. I am just saying that your triplet is going to be like this: A1, B1, and something from set C, A2, B2, and something from set C. A3, B3, and something from set C, and so on, so on. How many such is possible? Means I am not filling this part. I am just looking for distinct these. So how many such? There are m into n such, right? Now to include this, we have to pick it from here, and for each of this, you have p choices. You have p choices. So it becomes in a similar manner. It becomes what? For first one, you have p choice. For second one, you have p choice, and so on, so on. For m into nth one, you have p choice. So the number of elements become what? P plus, so on, p, which is equal to m into n into p. Okay. What about the product of four sets? Similarly, for product of four sets, what you will do? So for four sets, this is like principle of mathematical induction. If you were studious in your 11th and 12th, you would have understood this already, that we can apply mathematical induction to get the result. But I don't think that you were studious, just like me. So if it was four sets, then you know that there's going to be four tuple. There's going to be four tuple. Okay. So you know about, if you just take uh, if you just consider this region up to this, all the distinct elements in up to first three only, then you know that how many are those, m into n into p. And then for each such m into n into p, you have, let's say, for if you have a into b into c into d, if you have four sets, and let's say d has cardinality d, then for each such you have d choices, and then the cardinality of a cross b cross c cross d is nothing but m into n into p into d. Okay, so it's okay. Now let me just directly write. I have proven. So let's say if you have set A1, set A2, set A3, so on, set AK. Okay, then this is the product of such sets. What is the cardinality of this? This is equal to cardinality of A1 into cardinality of A2 into cardinality of A3 into cardinality of A4 into so on, cardinality of AK. This is the result. Okay, so product of sets is over. Let's get little bit about Cartesian product of sets. Actually, when you have only two sets, the product of two sets is also called as Cartesian product of sets. Why? Because think of Cartesian plane. Okay, let me explain. Cartesian product of sets. Cartesian product of A and B. It is just the product of two sets is also called Cartesian product, because you can represent the product of two sets in a Cartesian plane like this. Let's say this is one Cartesian plane. Okay, and this axis is your A, and this axis is your B. Means this axis will have elements of A, and this axis will have elements of B. Okay, let me take just A to be 1 3 5 and B to be 2 4 9. Then what is A cross B? How many elements will be there in A cross B? 3 into 3, 9 elements. So the number of elements in A cross B is equal to 1 and 3, sorry, 1 and 2, 1 and 4, 1 and 9, 3 and 2, 3 and 4, 3 and 9, 5 and 2, 5 and 4, 5 and 9. So this is 1, this is 3, and this is 5. And what are the elements in B? Elements in B is 2, let's say this is 4, and let's say this is 9. Okay, then you just plot it. You just plot it. So with 1, because we are talking okay, this is Cartesian product, so it is all possible pairs. So 1 and 2 will be each, everyone will have a point. So everywhere you will have a point everywhere. Similarly for 3, so this is something, the Cartesian product will be something like this only, because it is all possible pairs. Okay. In the next video we will read about relation. Relation is a relation is a subset of Cartesian product of sets. I will explain what relation is, but it's a subset. So subset means that some of the elements might be missing. Okay, even the Cartesian product of sets is also a relation. You know, the product of set, Cartesian product of set is also a relation, because every set, one of the subset of any set is a set itself. So this is also one of the relation. A cross B is also one of the relation, but relation is actually can be the proper subset also. So some of the, let's say that if you miss this point or this point, this is one of the relation. So this is the difference between Cartesian product of sets and relation, is that in product of set the dot will be or every possible dot, and in relation some of the dots will be missing, some of the dots may miss. In the next video we will talk about relation. Thank you very much.